Earth-orbiting satellites are now giving us vital information for us to understand what is happening to our planet, and in particular, to monitor climate change and to provide the tools that we need to make better predictions. Data are being received from all around the world on receiving stations from now many tens of satellites, and it's the range of information that's now coming is providing that comprehensive picture we need to understand how the health of our planet is changing and to monitor the planet's vital signs. We're at a crucial juncture because population growth now, large numbers of people, are putting quite a strain on the planet. We have, as a species, great demands of resources, and of course we are emitting greenhouse gases which are affecting the climate. So one of the most crucial things that we need to do is monitor the changes that are taking place and to produce long-term records of data that allows us to judge what exactly has happened and why it has happened. And this information is absolutely vital to politicians and decision makers as the fundamental scientific basis to allow them to implement policies that really lead to the right outcomes.
These old Antarctic suits remind me of my own trips to Antarctica. I was struck not just by the awesome beauty of the place, but also the dramatic changes that are occurring. Along the Antarctic Peninsula, we've seen ice sheets that are the size of Greater London and the height of a 10-storey building collapse in a matter of months in recent years. Earth observation, in combination with advances in numerical modelling of the climate, is essential for helping us to understand both present-day changes and future changes, and that evidence base is critical to underpinning future policy.
What we really need for studying climate change is continuity in the class of sensors that are looking at the planet. And it's always the case with Earth observation. You don't discover things until you start to look for them, and until you've got the tools with which you can look properly, we just don't know what's going on. The ice sheets are changing in a way today that we never thought was possible.
A good example of how Earth observation can support the implementation of environmental policy is the case of forests. So as you probably know, climate change is driven by greenhouse gas emission, which comes in a large part from deforestation and forest degradation. To try to tackle this, a lot of governments are trying to reduce this rate of deforestation and forest degradation. But to do so, they need to know where the forests are and how significantly this rate is changing over time. This is simply impossible to monitor at the scale of the planet at a relevant spatial and temporal resolution. And that's really where the strengths of the Earth observation are. By being able to look at our planet, to differentiate different types of ecosystem, including forest, we are able to support the implementation of those kind of policy by saying this is where most of the forests reside, this is how much we have lost over the past 30 years, and this is where we should concentrate our efforts to try to reduce deforestation and forest degradation and therefore reduce greenhouse gas emission.
Forests currently take out about 4 billion metric tons per year. They also release about 2.8 in terms of losses of carbon due to land use change. So that's a net sink of about 1.1 billion metric tons. So remote sensing helps us to monitor how much carbon is being released. If we have an estimate of the area that's been deforested, and we have an estimate of the carbon stocks for that area, then we can calculate how much carbon was emitted to the atmosphere. And conversely, we can see areas regrow over time using remotely sensed data, and we can therefore estimate how much is being taken out. And the importance of these measurements is that you have to have a very precise measurement in order to enforce policies that seek to reduce carbon emissions. So for example, if you emit a certain amount and you want to reduce it by, let's say, 25%, but your uncertainty is plus or minus 50%, then you'd have to reduce by 75% just to outstrip the uncertainty of your estimate. And so the contribution of remote sensing from that respect is just to get really precise estimates of how much we're emitting and how much we're taking out.